everybody. I'm Javier. Thanks for coming today to talk a little bit about microservices and basically how to migrate into them. The context of this is going to be around using CDC as a technique and Kafka and some of the tools of the Kafka ecosystem as a way to implement that. So what we are going to be talking about today is I'd like to recap a little bit on some of the challenges that I have personally gone through when I've done microservices migrations, which I imagine that many of them are not that different from what I experienced. So once we have established basically what's the problem, looking into how CDC as a technique and Kafka as a tool can help to mitigate some of the pains of the migration. Very quick demo, something very simple, nothing really fancy, but just so you see how the whole thing can work at a very small scale. And then we can look a little bit on what are the pros and cons of this technique, which is not perfect by any means. And some of the resources if you want to dig a little bit farther into CDC and Kafka. So, just a brief introduction. So I'm a technical architect here at Nutmeg. I joined in October, so I've been around for like half a year. My background is with .NET, despite what Giorgio said, we are basically a Java shop. So I come from the dark side. Found the light in 2015 and moved into the JVM where everything is green and beautiful. I've been doing event-driven architectures ever since, on top of Kafka and things like Kafka Connect. And also around the time I also started to understand that despite what I thought, which was that data is just a waste that is behind the execution of our applications, actually it's not like that, and is the new oil, so you need to take it very seriously and you need to give it the utmost importance. So let's talk about microservices migration. So I imagine that this is pretty much how you feel when you're working in your monolithic database. So you are driving your big ball of mud around. You know that every single person that ever worked in that code base was wrong about all possible things. It makes you very miserable. But it's even worse when you start looking at the data model. There's a million different tables in there. All of the columns are basically nullable bar charts. And there's probably even pages of JSON inside those columns anyway, so no one really knows how the data looks like, and also the older the data it is, the less sense the data model makes. So, and then also you're using the oldest technologies that you can even imagine. And if you're really lucky, you might have come across these systems that are so old that they have like geological layers, so you can see how the passwords were and disappear over the time. So like ORMs being a big thing and then being abandoned, service buses and whatnot. And it's all there for you to marvel how much the industry has moved forward. And if that wasn't enough, then you probably have a colleague that is working in an amazing new shiny code base, is riding unicorns to work every day with a smile. And you can only imagine how great it would be to be working with a stack like that. So eventually, basically, you somehow convince the business or the product owner or whoever that you have to move away from the monolith. Like, this is not really a good scenario anymore. And obviously, when you move away from the monolith, you do microservices because microservices is the answer to every problem, ever. Like, if there was ever a silver bullet, it is microservices. So you say like, okay, this is all set up, we're going to do microservices here, like good people. So then you go to the source of all information, which is Hacker News. It's a condensed wisdom of humanity. It's just one website. And there you are going to find all of the technologies that you should be putting into your new shiny stack. They have to all be alpha, because if they are beta, it's too mainstream for you. And you don't have fear anyway. And then you also start thinking about like, okay, what are the weapons that I can use to attack the problem, to do this migration. So you most likely are going to come across the strangle pattern. So cool, I'm going to be slicing slowly, wearing out my monolith until it gives up. I'm obviously going to come up with new data models because the old ones are insane anyway, so why would I? And you probably say to yourself, I'm a conscientious developer, so I'm not going to throw all of this into production into the wild, just like that. I'm going to do a little bit of traffic shadow weight, so I'm more confident that what I'm putting in production is more or less working. And you probably end up with something that looks a little bit like this architecture. This looks like it's been drawn by a 3-year-old, but it's me, actually. I like drawing, so anyway. So you might come up in one of these two flavors. Either you have a microservice that is just sitting on top of your monolith database. It doesn't really do more than reading and writing from this database. Or maybe you decided that, you know what, for all of the new data, I'm going to use my own data storage, and only for the data before the day of the release, I'm going to be still sitting on top of the monolith. In any case, you're not really leveraging much of the value of the microservices. Instead, you are in microservices. So you probably now have two sources of truth, because for the same type of entity, you might be storing two different databases. You have to add new features into two different places because the monolith is still there, and you still need to take care of it anyway. You have two tech stacks. And actually, now going back to the monolith code base is even more painful than before, because now you know better, right? So you realize how bad that thing is. And in any case, you're not leveraging the classical microservices advantages like, okay, I can scale this thing independently in terms of resources. Well, you cannot, because you have the congestion with the monolithic database anyway. And you cannot also scale in terms of organizations, like having teams that can be looking at different sets of microservices, implementing domains, because everyone is still living together in the monolith anyway. So at that point, I think that you do the most sensible thing, which is you apply the strangle pattern to yourself. Basically, this is game over. Why this happened? Okay, because no one really tells you in microservices school that the hardest problem about microservices migration is the data migration, or actually building the microservices. Someone said this in internet, possibly. And if you, for instance, as an example, if you search for the strangle pattern, and I think that the first result that it comes is from IBM, so it's the developer website of IBM. You search inside that article about the strangle pattern, there is zero mentions to data. It's like data is not a thing when you do a microservices migration, and it's quite surprising, right? Like no one really wants to talk about this, but it's a big problem. So is there hope? Can we do something about this? Well, there is. It's not easy, so I'm not gonna lie to you, and you might still fail. But there is probably a better way. So first of all, I think that you should understand your data, but it should be end-to-end. And when I talk about understanding data, I'm not talking about knowing your tables and your columns. What I'm talking about is understanding your data as a collection of business entities, and understanding what is the life cycle of those entities, what can happen to them, and when. Then you start thinking about, okay, I need to slice my monolith. And everyone has a slightly different recipe regarding how and where you should be slicing your monolith. For me, I think that it's very important that you maintain the transactional boundaries of the information, and as such, the aggregate roots of the DDD methodology are a very reasonable design technique, because that's exactly their focus. What the focus is on making sure that you put in together in the same microservice things that have to be kept together and has to be changed together. And then another big thing is that you start thinking about your data migration from the day one. My experience is quite often people will build all of the microservices, and I've done this, so by all means, don't think that I haven't made all of these mistakes. You build all of your microservices, and then at the late stage you say like, oh, by the way, we need to migrate the data. Let's think about that. And then you have like another 10 months until you actually get to migrate all of that horrendous data that you have in there. So don't really procrastinate that, even if it is painful. You need to do this as soon as possible. You need to start thinking about this as soon as possible. And finally, don't really treat your migration as a one-off. You think that you're going to be able to run one big SQL script and dump the data from A to B and you're going to be done. That's not how it's going to go. It is going to be a constant process. And actually, the data should be flowing from the monolith to your new microservices, and eventually it might start flowing back because you might have moved the data out of the monolith, but you might still need to do integration back of that data into the monolith for readers that are still accessing the data in the monolith anyway. So it's going to be moving in one direction, it's going to be moving back in the opposite direction, and it's going to constantly be happening, and it might be happening for months, even years. So forget about this as a one-off thing. It's not going to work like that. So once we have described a little bit what are the challenges, one of the biggest challenges in microservices, how can CDC help basically tackle this problem? So let's say that you have ticked all of your boxes. You know your data, you have talked to your business people, and everyone has an opinion on those things and how they change. You have nailed your microservices, you have sliced them exactly the right proportion at the exact right endpoints and integration points to minimize coupling. You know how you're going to migrate your data from the old model into the new one and vice versa. So the last piece is basically making sure that that's a continuous process. And this is where something like CDC can help you out. So CDC stands for Change Data Capture. And it's basically an approach for data integration that is based on identification, capture, and delivery of changes made to enterprise data sources. That's a little bit fluffy, but what it means, and especially in the context of Kafka and Kafka Connect, and here I'm going to assume that people have some understanding of Kafka, at least at the very high level, basically as a system that is capable of delivering information in a continuous flow. If you don't know about it or you want to ask me later questions, please feel free. But otherwise, the scope of the talk will fit in half an hour. So basically, well, CDC in the context of Kafka and Kafka Connect, what is going to happen is that you're going to have Kafka Connect, which is a data integration tool. It's going to be constantly consuming the transaction log of your database. So the transaction log of your database is basically a file, right ahead log that is what actually provides the ACID capabilities of your database, so the ability to things be durable and being atomic, so on and so forth. What Kafka Connect does is that it's constantly reading from there, and then it converts every single insert, update, or delete that happens on your tables, the tables that you have chosen to monitor and consume, converts every single one of them into a Kafka record. So what is happening is that basically you're changing something that is a constant mutation, because every time that you update something or delete something, you have like a final snapshot of how the data looks like. Instead of having that, just one single snapshot that has been aggregated over time, you are basically capturing everything that has ever happened and sending it over for anyone to do something about it. So that becomes a continuous stream of change that's happening to your database. And then on the other side, once you have ingested all of this information into Kafka, what you can do is that you can consume that at your own pace, and also you can consume this horizontally, meaning that you can have as many consumers as you want, and as long as the data is spread across the cluster, it's always going to be able to handle all of the load that you throw into that problem. So in the end, what you start doing with this is basically freeing up your data. It's not locked down into your monolith database anymore. So roughly, how this would look like is like you have a number of tables that you have chosen to consume, and they end up represented in Kafka as topics, and every topic contains a series of inserts, updates, and deletes that represent what has been happening to those tables since the point when you started consuming them effectively. From there on, you can insert that data into other microservices or compound them to create materialized views, different things. So by the faces that I have in front of me, I think that right now is pretty much how you feel. It's like, slightly lost now. So let me put it step by step, so it's a little bit clearer. So step 0 is that you design your data migration. Okay, so you know that you have an old model for let's say a given table. You know that you want to have a new one, and then you, no matter what way you think about this, you need to design how you're going to be converting from old to new, unless you're willing to throw away all of the old data, which I imagine that you cannot, pretty much in any possible way. So that's pretty much common sense. Okay. So apart from doing that, I'm also saying that you should think on the reverse. So you should think on, okay, how can I convert data from new down to old? And actually, that's easier because if you think about it, normally your new model is probably, or the expectation is it's going to contain more data. For instance, you might have, I don't know, like a payment record for someone that has done a payment, and that payment didn't contain where that payment, that record didn't contain where that payment happened before, and now you want to record that piece of information because maybe your company used to operate only in the UK and now it's operating in multiple geographies. So what you can do there is say like, okay, all of my old records, they don't contain the country of the payment. The new ones, they have to. So what you can say is like, okay, my new model is going to have a country, and in the absence of a value, I'm assuming that the country is the UK, because I know that all of the old data happened in a country that is the UK. So this is the kind of design that you need to start thinking about, like, okay, how I'm going to upscale my old records to the new ones, and also how I revert that process. And this is going to be helpful also when you're testing. Because if you can convert in one direction, then you can also, using the opposite direction, convert back and see if you are at the beginning and you haven't had any data loss. So you design this migration. And then once you know how you're going to do that, right, the next step should be to kickstart your microservice before anyone is even using it. It's like, okay, I have this microservice. How do I kickstart it? Well, you need to populate the microservice database. I'm assuming that you realize that sitting on the monolith database is giving you nothing. So you spin up your database for your microservice, and then you start populating information into that database. So again, instead of assuming that this is one thing that you're going to throw over the wall once and you're going to be able to forget, instead of designing it like that, you design it around the CDC idea, which is data is basically going through a constant stream of changes. For every single change that happens to entities in the old database, you inject your migration from the old model to the new one, and then the data converted into the new model lands into your new microservice database. So you keep both sync, which is very important, and also you can guarantee that you have all of the information that is always in the monolith database now in the other microservice database. And you can take as long as you want. Eventually, you're going to catch up. Right? Depends on how big those tables are. If they have terabytes of data, it might take weeks to do the whole migration. If there's megabytes, it might take a minute. It doesn't matter. What matters is that eventually it's going to be ready. Right? And you basically constantly convert it. Once it is ready, this is when you start thinking, okay, I can start bouncing some of the clients away from the monolith and into my new microservice. Right? So you can take, let's say that you have a simple reader that is just reading about this entity. It's not doing more than that. Cool. This is the easiest possible case that I can imagine. So you change your consumer, your client, to start using the new API. Right? So this is a very simple scenario. You just start hitting the new API with the new data model. Contract or whatever it is that basically is representing that. And you know that everything that is being written as we speak into your monolith is still constantly flowing all the way back to your new microservice, so there is no data loss in there. If you go to that database through that endpoint, you're going to find the data that you need. Cool. So that's relatively simple. here is where the most complicated stuff comes. The writes, right? So this is a critical step, because this is basically when you're finally transferring the ownership of the entity away from the monolith and into the new microservice. Whoever is writing, like wherever the writes are landing, that is your source of truth, right? Because you don't want to have more than one. You want to write only to one place, and you don't want to write to many. If you write to many, then you have multiple sources of truth, and then you have bigger problems. So you bounce all of your writers away from the monolith into the new microservice with a new endpoint or whatever, and now you start reverting the direction of the migration, right? So now, instead of moving your data from the monolith to the microservice, you do the opposite, because now the microservice is the source of truth, is the place where the writes are happening, and the only reason why you still need to send the data, in this case in the opposite direction, so back to the monolith, is because most likely you still have processes hitting the monolith that need to know about the data changes that happen, in this case in the microservice, in the new microservice. If you don't have any reader, then you don't have to do this. Assuming that you still have some, this is still going to be needy. And that's why it's handy to have the migration designed in both directions, because you will start migrating from old to new, and eventually you will have to migrate from new back to old, until there is no more readers hitting your monolith. Once you have moved away every single piece of every single process that wants to have access to that information away from the monolith, then that could be the point where you stop integrating data back into the monolith. And if you have complex readers that basically are joining multiple tables, if you start doing CDC with multiple tables as well, then you can start thinking about building materialized views of these guys. So that means that you can also benefit from read models that represent multiple different entities that are ready-made for your complex reader to hit, instead of doing joins on the fly with all the performance implications that has. So at that point, basically, if you achieve this with every single entity in your monolith, then you can kill the monolith, because no one is actually using it anymore. And it's been a step-by-step process. There's not been a big bang sort of approach where everything used to be in the monolith for something, and then everything is away from the monolith in one big deployment. So I'm going to do a very quick demo, just like very basic stuff. So what I have here, let me actually show you first of all. So I'm going to be bringing up, actually I have a slide display. So I'm going to bring up a Docker container that has in it Kafka and Kafka Connect. So this is for testing. It's definitely not something that you should ever consider doing in production. I'm also going to bring up another container that is going to be like a MySQL database. So this is going to represent my upstream database, as if it were my monolith database. And then I'm going to run an application that is going to be inserting one record into that database every second. So very simple. And then I'm going to spin up a consumer, and we're going to see how the application reports that is written to the database, and immediately, pretty much at the same time, the consumer says, I've been able to read this from Kafka, not from the database. So basically, the whole process of from your database to Kafka, and someone consuming from Kafka is instant, which is easy because I'm running this on my machine anyway. But it's pretty much as immediate, real-time-ish in a production environment. So the first thing that I'm going to do is I'm going to start my cluster, and while the cluster starts, just quickly going to look at it. So basically, this is a Docker compose that I'm using. It's very simple. I'm just exposing some of the ports for some of the products. This thing is basically hosted. This thing is from the guys in Landup, although I made a small modification, that's why I'm using mine. It's very useful when you are working with Kafka, because in one single container you can have everything that you need to run Kafka, to run Connect, and some of the pieces of the Kafka infrastructure So this is basically bringing that up. It's also bringing up Prometheus and Grafana. So Kafka exposes metrics using the JMX Java registries. So it's very, very easy to know what's happening in there, basically monitor metrics and stuff like that. And then I am going to run my application. So what this is doing is it's creating a topic for, well, actually two topics. So it's basically screw it up running the wrong thing. Okay, I'm bringing everything up. So basically, while this runs, let me show you what we are going to be running. So we're going to run flyway migration simply to set up the upstream database where we're going to be inserted. Then we're going to bring that database up, waiting for basically for my SQL to be ready. And then we are going to be running the application that inserts into the database, and we're going to post to connectors. So connectors is basically the thing in Kafka Connect that is responsible for pulling the information into the transaction log and sending that over to Kafka. I can't guarantee that it was working literally an hour ago. Yeah, maybe. Programming or something. Yeah, maybe I have. Yeah, maybe I have some containers that I still. That's fine. Yeah, yeah, it's probably an orphan. So I'm gonna stop this one. I'm gonna make sure that I get rid of. Alright, so I'm going to continue with the pros and cons and then come back to the demo while local research because it takes ages. It takes ages to run. I don't want to take longer than we should. In terms of like basically what are the pros and cons of this technique? So for me, it is very important that basically with CDC it enables you to do gradual migrations because of this constant flow of information. So you can basically, as we saw, bounce readers first, and eventually once you are more or less confident with your microservice and like test it with real use cases, not just with shallow trafficking. Basically, you can start thinking about, okay, now I'm maybe moving my complex readers after that, or maybe I'm moving my writers, but it basically gives you the option to move gradually instead of just big bangs altogether from the monolith endpoints down to somewhere else. Which I think that is one of the reasons why people usually end up not doing it, because it's so scary that they rather stay sitting on top of the monolithic database. And it also sets free your data in your monolith because it opens the door for many different use cases, including Otherwise, you're not going to be able to do with the data that is kind of like locked down in your database. Also, with this technique, your microservices availability is not bind to the monolith anymore. And by availability, I don't mean only the binary availability of whether the monolith is up or down. I also mean that something that probably some have come across, which is, okay, sometimes your monolith is busy because there are things happening in there and in the database that basically slow it down. So those times your microservice start trying to use the monolith database, it will make your microservice really slow. If your microservice is literally sitting on its own database and the data is just landing into your microservice, the worst that will happen in that case would be that maybe some records are not in your database yet, but when it comes to the SLAs of your microservice API, it's not going to be affected by anything that is happening in the monolith database. And you can also start thinking about building more sophisticated materialized views on top of multiple tables as a strategy to, again, move away some of your more complex readers. And for me, from not making this case is very important, we are building an event-driven architecture, and it would be amazing if we already have all of these events floating around our system. But the reality of it is that it takes a long time to design them all and implement them all either in your monolith or in your new microservices. In the meantime, the stream of inserts, deletes, and updates that come from CDC, I call them poor man's events because they still inform me of what is happening on those entities, and as such, I can start thinking in terms of reactive systems built on top of these events. They're not as good as properly business model events, but it's better than having nothing, and it allows to move into that space gradually again. Away from big bangs. The cons is, I already said that the writers have to be migrated all together. You can not do that if you want, but I think that is going to be a world of pain. Every time that you have some entity and there is multiple masters for that entity, it's always very, very painful. So I would try to avoid that at all costs. It requires careful governance on the schemas of the databases that you are doing CDC with. Because when you change those schemas, you have to do that in a backward compatible way. Otherwise, you're going to break the consumers that are downstream. There are a number of tools that can help you, including Abro and Schema Registry, if anyone wants to look into that a little bit more. So I think that it's not like completely crazy, but you need to be careful. And in general, it's a good thing to have in mind backward compatibility for any possible change that you do anyway. If you have some clients that absolutely need to read their own writes and they expect immediacy, if they are writing to the monolith and then reading from the microservice, there's going to be some latency. I think that is tolerable in pretty much all possible scenarios, or many possible scenarios, because the time that the client is going to take to send another request through the network, passing through things like LinkedIn or whatever it is that you put in between your microservices and your clients, API gateways and whatever, by then data is going to be synchronized in your microservice, but it's something that you might need to think about. And this is kind of like a little bit of a personal opinion. I think that this is a very, very good technique to migrate away from the monolith, but I don't think that it should be used once you land in your ideal architecture. Once you are there, once you have integrated all of your data, move away from the monolith, I don't think that you want to do CDC. I think that the job is done, and then you can move into other things like running on top of proper events, or just having your microservices with the little databases managing their own entities without any understanding of the monolith. So it has a time, and then that time is over, in my opinion. If you want to read a little bit more on this, Adam is going to be sharing this. There's a couple of links on the various pieces that are very important, including how to do this technique and why it makes sense. I am going to try again quickly to do this. If it doesn't work, then
Just stop.
okay.
Or you can come back to it at the end if you like at the end of the evening if you
I think that I'm
it running.
going to give it a go. Yeah, so what is really annoying is that I ran it a few times today. It was fine all the time. So, but I don't know how that MySQL container ended up like orphan. And I think that that's basically what has caused the issues. So anyway, this is bringing up again Kafka and all that stuff. Hopefully, I'm gonna be able to post this in a second. So this is bringing up the upstream container. Maybe. So I guess that is a good thing. Also, I think that when this runs on battery, Docker performs a little bit better. Um, any questions so far while we wait for this to come online? Okay, so this is basically bringing the container, creating the tables, compiling the application that is going to be inserting stuff into it. Yeah, but doesn't take time to compile. It's always immediate as well. And I'm going to have ready. So this is now inserting, right? And if I'm right, I have now, I should be able to consume the information that is going into the database, bin CDC from the transaction log, and then send to Kafka for any Kafka consumer, including this Kafka Avro consumer, to be able to consume. Maybe if you want, maybe just hate me today if you want to do anything, because why would it? Alright, well, I'm probably going to give up by now. I don't know. This is definitely not what should
We know what it should have done, right?
Yeah, exactly. So what you should be happening is that you can see here basically all of the messages coming. And the other thing that I was going to do, if I have had some time, so basically you can connect here with the J console, which you don't see. And then you can start basically look at all of the many metrics that this is going to be basically monitoring for you. This is basically a place where you can look at those metrics and start thinking which ones you want to throw to things like Grafana for alerting, or Prometheus if you just want to collect everything, whatever. But basically, we're going to look at some of them just quickly, but sorry, I've already run out of time, unfortunately. Finally, if you want to reach out, want to ask questions, maybe get the version of the code that actually works. Just ping me of any of these, Twitter, LinkedIn, or my blog. I write 2 posts a year, so they are all the gems. If you want to know more and get your hands dirty, please join us, because we are building cool shit with Docker, Kubernetes, Kafka, and all of these things. So we're writing unicorns to work every day. Thank you.